Okay. So we were doing this sum. What were we doing? We were trying to find out inverse of this matrix using row transformation we have already done. And now we are trying the same thing using column transformation. Okay. So column transformation ke liye, I think the first step we have already done. Now coming to the second step where we are about to execute this jump. C2 becomes minus 5 times C1. So C1 is not changed. It's as it is. C2 will be minus 5 times C1. So C2, this term, C2 over here, that will be minus 5 times C1. So it will be minus 5 by 2. Here again, C2 will be minus, C2 becomes C2 minus 5 times C1. Okay, so that's 1. Okay, so now we have made this also 0. So abhi our major aim is to make this 0 and ye wala number ko we have to make it half. Okay, so as I said, you have to follow the same procedure that I told you in the beginning, the order in which you have to make them zeros and ones. So the next step what we can do is mm, after C2 minus 5 times C1. Now what are we doing? C2, right? This is our C2. Isko we have to make it 1, correct? So we have to make this 1 and making it identity. So this is already half. How can half be made 1? Only by multiplying this with 2, correct? Only then 2 and 2 gets cancelled and this becomes half. So the next step is C2 becomes 2 times C2. Alright? So inverse as it is. C1 ka column remains unchanged. Just a second. Okay. And then C2 will be 2 times. So 0 into 2 doesn't make a difference. And this will be half into 2. That again gives you 1, which is equal to, here again, C1, no change, as it is. C2 here, I'm going to multiply minus 5 by 2 into 2. So that becomes minus 5. 1 into 2, then becomes 2, right? Yes, so now the one remaining thing is only about this term. Half को सिर्फ 0 बनाना है, then this will become an identity. So then we can easily tell that A inverse का value is equal to this answer. How will we make half को 0 बनाना है? So half again when it gets minus, right? Half minus half easily gives us 1. So again with the help of this one, like what we did in the previous sum also when we were doing using row transformations. अभी इसको 0 बनाना होता है, we used to always take help of the previous row का 1 को help लिया था. Now this we're going to do it ulta, right? So this one ka help we will take. So A inverse, let me just write what this thing we're going to use. C1 becomes C1 minus half times C2. Okay, we did it half minus वहां पे किया था ऊपर वाले रो को यूज करके, तो हम ये वाला रो को चेंज करेंगे with the help of this two. So now same thing, A inverse C1 the change, C2 as it is, so we'll just write it. So this becomes 1 uh, minus half times C2, correct? Yes. So it becomes half minus half times C2. That's 1. Half minus half is again equal to 0. Okay. So then now we're just doing it for the next one. C1 is changing. C2 there is no change. I will write it as this. C1 as it changes half minus half times minus 5 by 2, correct? So that's C1 minus half times C2. So C2, whatever it is, as it is, we'll write. So the answer is this. Everything, all the calculation, you should do it on the rough side. But right now, I don't have that much space. So I'm writing it over here. It becomes half plus 5 by 2. So what is the answer? This is nothing but common denominators. So denominator can be taken common. 1 plus 5 is equal to 6. So the answer is 3, right? The first answer is 3. And likewise, 0 minus half times 2. So that gives me minus 1. Okay. So this is nothing but A into identity. So this is not the way how you're supposed to write in the exam. All the rough calculations, you have to do it separately. But right now, since as I said, I don't have much space, I've written it here only. But please do that. Take care of the calculation. This is nothing but A inverse into I, which is equal to 3 minus 1 minus 5 and 2, correct? Now, as we know that anything we multiply with the identity, we're going to get the same thing. So A inverse will be nothing but 3 minus 1 minus 5 and 2. Let us just check with the identity that we got with the row transformation. What did we get there? 3 minus 5 minus 1 and 2. Here also 3 minus 5 minus 1 and 2. So here again, inverse is always unique. As I said in the previous video, inverse is always unique. Just 2 into only half can give you 1, correct? 2 into any other number we multiply, that the answer is not going to be 1. So inverse is always unique even in terms of matrices. Okay. Now let us do it for order 3 matrix. So whatever we did it for order 2, let us do it for order 3. But this time let's just do it for one type of transformation. I did the previous one using both the types of transformation, row and column, so that you just understand the difference between the two. But I think right now for the next sum, order 3, I'm just going to do it using row transformation. So you have to find out inverse of this matrix. Okay, using elementary row transformation. If it's given in the question, then you just have to use that one transformation. Okay, suppose this is a question. So what was the first step we did initially? Inverse can only be found out if that determinant is not equal to 0, correct? So determinant 2 5 0 0 1 1 minus 1 0 3. Okay, so with this determinant value, we're going to find out how do we find out the determinant of this thing. We take the first element, just take it as it is, and then kind of hide the row and column in which that element lies. Suppose I'm just crossing out that row and column in which the element lies. Suppose it is like this. Okay, this 2 we have taken, so I'm just trying to cross out the element that in which the element 2 lies. Okay, then we can write down whatever remains in the form of order 2 determinant. So that will be 1 1 0 and 3. Okay, so it's alternate plus minus. As I said, the next number ke liye you will put a minus sign, because yahan pe it's just 0. Anyways, that does not make a difference, but in case if you have any other number other than 0, then you have to take care. So now we have selected 0. So 0 kaun se row aur kaun se column mein lie karta hai, that you just see this row and this column, correct? This row, this column. So we'll just cross out that, and whatever remains, we're going to write it. 5, what remains? 5, 0, 0 and 3. And the next one, the sign will be as it is. Okay, there is no change. So minus 1, this row and this column. So we're going to edit that, and then whatever remains, 5, 0, 1, 1. And order 2 ka determinant, how do you find it? I just taught you all. So we're going to follow the same step. So 2 into, we can just use types of bracket, bigger bracket, so that it's easy for us to calculate this one, right? 1 into 3 minus these two, 0 into 1, minus of 0 into, in case if you would have some other number other than 0, then you were going to calculate, but right now since you don't have anything else, you can leave it. I'm just showing you, agar koi aur number hota, then you will have to calculate, correct? So that becomes 5 3s are minus 0 into 0, all right? Minus 1, and then that's 5 1s are minus 0 into 1. Okay, so this is twice 3 minus 0. Minus 0 into anything that becomes 0. So even if you don't write, it's okay. And then minus of, that's 5 minus 0, right? So the final answer is 2 3s are 6. This is 0. This is minus 5. So the answer is 1. 1 which is not equal to 0. Here we have determinant of A which is not equal to 0, which implies inverse of A exists. Okay, A inverse exists. So we can find out A into so A into A inverse, which is equal to I. So we go to follow the same step, what we did it later last time. तो A into A inverse. Again क्या करना है, वो जो A है उसको आइडेंटिटी बनाने का. Then identity into A inverse, whatever answer comes over here, that will be the value of your actual inverse. So let us write A is, we have to careful with this one. 2 0 minus 1 5 1 0 0 1 3. 0 1 3 into A inverse, which is equal to identity. But that identity अभी तो ये order 3 का है, so we will write order 3 वाला identity. 0 0 1. Okay, so now we're going to make this identity using row transformation, and then fit whatever corresponding the operations that you perform, you have to perform the same thing for this element as matrix as well, and then you will get the final answer. And the order in which you have to make zeros and ones, that I already mentioned it in the beginning, so please have a note on that. Okay, so what we can do is we can the pehle to we want that one, correct? So what we will do, we can make we cannot easily get one. It will become like a fraction, correct? So dividing that by 2 gives you 2 by 1 is 1, that is 0, and this becomes minus half. So instead of getting that into fractions, of course the procedure is making this one first, but what I wanted you all to suggest is, in case अगर तुम इसको 1 बनाने के लिए, it's not just the only way of dividing by 2, there's another way also. Suppose अगर ये 2 है, and in case if we divide, in case if we multiply that entire first row with 3, then becomes 2 3s are 6. 6 में से if we multiply the second row, we can always get that above thing is 1, right? So as far as possible, you should avoid the complicated terms. So we can make R1 changing to 3 times R1. Okay, so 3 times R1 I'm doing. Why am I doing it? I'm doing it purposely so that this becomes 6. For next step, I can do 6 minus 5, 1. You can do it any way the way you want. Okay, so 2 3s. So the entire row 1, we're multiplying it with 3. 2 3s are 6, 0 into 3 0, minus 1 into 3 minus 3. It's 5 1 0 0 1 3. A inverse as it is, and the first row here again multiplying by 3 0 1 0 0 0. Okay, now of course that is what our main major aim was, to make this 1. So now we'll divide. R1 becomes, sorry, we'll subtract. R1 becomes R1 minus R2. So this is R1 minus R2. So the change is taking place only in the first row. Second row and third row, you can write it as it is, so that later on you don't have any kind of confusion. Either way, you can write it, okay? Because we know that the first row is only going to have some change. So second rows, we can write it as it is. R1 minus R2, the 6 minus 1 is 5, 0 minus 1 is minus 1, minus 2 minus 0 is minus 3, 3 minus 0 is 3, 0 minus 1 is minus 1, 0 minus 0 is 0. Okay, so after doing this much, now what was our aim? Our aim was to make these 0, right? This one we had to make it 0. So now when you have to make this one 0, I already have a 1 above. This if we did it in the previous sum also. We had a 2 over here, or some number over here, and then यहाँ पे 1 था, and we wanted to make this 0. So whenever you want to make something 0, you can always take help of that row, just make 1 है उसका corresponding row. So then with that help you can easily make it 1. So R2 is going to go through a change. R2 becomes minus 5 times R1. Okay. Why am I doing it? So then 5 minus 5 gives me 0. So only the second row is going to go through a change. So I'll write the remaining rows as it is. Of course, you can do it row 1, then row 2, then row 3. That way also you can do. But it's just that जहाँ there are changes, we can just leave that place, and then we can fill it later. So this way also we can do. 5 minus 5 times 1. 5 minus 5 into 1. So 5 minus 5 is 0. 1 minus 5 times minus 1. So 1 minus 5 times, that's nothing but 1 minus 5 times minus 1 is 1 plus 5, that's equal to 6. Likewise, 1 minus 5 times minus 3, so the answer is 50. Okay, so you can just do it for this one also. That becomes 0 minus 5 times 3. So that becomes minus 15. 1 minus 5 times minus 1. This is what the same thing that we had done. इससे पहले भी 0 minus anything that becomes 0 only. So this is what we have. Now what did we want? उसमें फिर क्या लिखा था? A22 लिखा था. A22 को 1 बनाना है. But here if you see A22 का 1 is already there over here. So instead of making that 6 को 1, we can clearly kind of interchange, right, these two rows R2 and R3. So ये वाला 1 यहाँ पे आ जाएगा और A22 का जो value है, this is I'm following the procedure that was given in the beginning, okay, which is I think mentioned in the last or last to last video. So here I'm going to interchange these two rows, R2 and R3. So R1 there is no change, R2 becomes R3 and R3 becomes R2. A inverse, which is equal to 3 minus 1 0 and 0 0 1 minus 15 6 and 0, alright, so R2 to R3. And now what can be done? Now we know that this term, correct? Okay, so now what are the changes that we need? यहाँ पे we need 0, here also we need 0, then these zeros, and then here we need 1, correct? So to make it identity. So what we can do is, by the way, you can perform two operations together as long as the two are not like continuation to each other. For example, something like this. अभी देखो अगर हमने R1 और R2 को add किया, like we have want to make this also 0. So we can add this to minus 1 plus 1 so that this becomes 0 in such a way that this 1 and 0 that we have already got it after so much of efforts, that should not get affected. So yes, after adding row 1 and row 2, the things that we have already got settled, that is not affecting, but and we're also getting the things what we desired. Okay, so we will now make R1 changing to R1 plus R2, and here also we have to make some kind of change, right? So then what you can do is, here also again we want to make 0, but abhi see ye wala isme only row 1 is going to change, correct? Row 1 is going to change, row 2 is going to remain as it is, but I also want to make this thing 0, so I'll take the help of this to make this thing 0. How will I do that? R3 becomes R3 minus 6 times R2, so then this also becomes 0. So both the operations you can perform in the same step. By any chance R3 को अगर हम some 0 or 1 we want to make, but with the help of R1, that we can't do it in this step because R1 is also changing in this step, so we can't do that immediately in the step, right? So then you will have to take it in the other step. But यहाँ पे R1 R2 के help से हो रहा है, R3 भी R2 के help से हो रहा है. So they're like disjoint, no? R1 and R3 are not getting affected, the ones that are changing, correct? So we will do R1 plus R2, R1 plus R2. This is also R1 plus R2 0. R2 there is no change. R3 becomes R3 minus 6 times R2. R3 minus 6 times R2. R3 minus 6 times R2. 15 minus 6 times 3. So that's 15 minus 6 3 is 18 is minus 3. A inverse, which is equal to, and then R1 plus R2. 3 minus 1. 0 plus 1 is 1. And then R2. No change. I can't direct. Just a second. 1 second. So this is okay. So we're adding, right? Okay. So this is R1 plus R2. As I said, this also becomes 0 plus 1. R2, there is no change. And then R3 minus 6 times R2. So this is R3 minus 6 times. It's not going to make a change because that is 0 only. So 0 minus 6 times 1 is minus 6. Okay. So we're almost done. What are the things that we want to change? This thing should be 0. This thing should be 1. Correct? So we can make this 1 first. So how are we making that 1, we can divide throughout by -3 to make this 1 correct. So R3 can be changed as -1 by 3 R3. Okay, so R1 and R2 no effect. R3 dividing it by 3, so 0 doesn't make a difference, which is equal to here again R1 as it is. यहाँ पे this will be divided by -3, so -15 divided by -3 is 5. This will be -2, this will be +2. Okay. Now the only thing that we want is इसको 0 बनाना है. So that is easy, right? So we can make that easy. R2 is changing to so we can do that R2 minus 3 times R3. Yes, with the help of the third row, we can find out R1 and R3, there's no change. 0 minus 3 times, 1 minus 3 times, and then this is 3 minus 3 times 1. So that's 0, which is equal to R1 and R3, there's no change. R2 becomes 0 minus 3 times. So that becomes 0 minus 3 times 5, so that's minus 15. 0 minus 3 times -2, 6. It's 1 minus 3 times 2, so that becomes -5. Alright? So here again, this is what we wanted. Identity into A inverse, which is equal to this full thing, 3 minus 15, 5 minus 1, 6 minus 2, 1 minus 5, 2 as it is. The same procedure that we have done. Identity into anything is same number. So the final answer is 3 minus 15, 5 minus 1, 6 minus 2, minus 1, 1 minus 5 and 2. Okay, so this is using row transformation. The inverse of A is this thing. Since Mr. row transformation puja hai, so we're just doing row transformation. Okay, so whatever they ask, you have to stick to that. Now, what if another method, not by transformation? Okay, so there's another method. Right now, we are only doing row transformation and column transformation, and then we're finding out inverse of A, correct? So the other method is by adjoint method. So that we're going to do. That again applies for the same if it has to be a non-singular matrix. Matlab, the value of the determinant should not be equal to 0. That's true.